about the chemistry of glow sticks.
By Ben Young and Caleb Kolarov. What are glow sticks? Well, glad you asked. Glow sticks are temporary, colorful light sources that is inside a small plastic tube can, that contains chemicals and chemical dyes. They are mainly used for camping, exploring, partying, and military services, as well as other things.
How do glow sticks work? Chemiluminescence is the emission of light. Light is emitted purely from a chemical reaction, and no heat is provided. The glow stick's outer plastic tube holds a solution of oxalate ester and a colored dye along with a glass vial filled with a hydrogen peroxide solution. You then snap the glass tube that starts the reaction, releasing the hydrogen peroxide. When the chemicals mix, it goes through a reaction, releasing the light.
Inside the dye of the glow sticks, fluorescent light. Inside the dye, the fluorescent dye determines the color of the light emitted. Different dyes emit different chemicals corresponding to different dyes emit different chemicals corresponding to different colors. Common dyes would include rhodamine B, which gives us that nice red color, 910 bisphenol phenolethanol anthracene, which gives us that nice green color, 910 diphenylanthracene, which gives us the blue color.
And to the right here are the chemical structures, which are, and there are the steps to get the excited dye.
Tell me about the temperature.
Alright. Different temperature drastically changes how fast, how bright, and how long it lasts for. Higher temperature has faster reactions, brighter glow, and shorter duration. Lower temperatures, like put a glow stick in ice water for example, slows the reaction down, has less glow, but a longer duration. The concentration of reactions, the higher the concentrations lead to a brighter but shorter lasting glow. Some glow sticks use catalysts like sodium salicylate to speed up the reactions.
What's the history? I got it. Glow sticks were invented in the 1960s. They were known as Ceolum at the time, but weren't mainstream until around the 1980s. During research on fireflies, scientists discovered that the bioluminescent light was made possible without heat due to the use of chemical compound luciferin. And before this, light wasn't really, common without some sort of heat like fire or light bulbs. Edwin A. Chandras is known as one of the founding fathers for glow sticks, as he accidentally created the necessary compound for glow sticks when he was experimenting one day with luminol.
Here are the chemical steps in order to get the glow stick to work. First, you bend the glow stick that breaks the inner glass vial. Hydrogen peroxide and phenyloxalate solutions mix. Phenyloxalate ester reacts with hydrogen peroxide. Then high energy intermediate forms, 1,2-dioxetane-dione. The higher energy intermediate decomposes, releasing the energy. Then the released energy excites the fluorescent dye molecules. Energy is released as light, and then that is what the glow sticks are.
On the left, we have a little diagram that shows you how this chemical reaction takes place. At the very far left, we have trichlorosalicylate oxalate ester, which then becomes our H2O2 base, which is hydrogen peroxide, and then is added in combination with the and then that becomes the dye. And then there's the dye, 2CO2 plus dye equals dye plus light, I think.
Yes, that is correct. Okay.
Thank you.
How they are made. Hydrogen peroxide, tert butyl oxalol.
Fluorescent dye. To begin with, they have a plastic casing on the outside that contains a small plastic. To begin with, they have a plastic casing on the outside that contains a small glass tube. Outside the glass tube, there is trichlorosalicylate oxalate ester, also known as hydrogen peroxide, which is what activates the glow.
Did you know, Caleb, inside the glass tube, there's also dioxytanedione, which are phenyl oxalate / fluorescent dye.
I did not know that, Ben. That is sick.
Now, here is our video that we've made for you, Mr. Jones.
What's up, guys? Caleb and Brandon.
Ben's behind the camera.
Ben is. So what we're going to do is we're going to take the hydrogen peroxide and then mix it with the phenyl oxalate. So,
We have to cut the glue sticks first.
yeah, oh my god. Whatever. We're going to take the hydrogen peroxide from here. Then we're going to take this big boy. Oh wow, that's actually a lot. Hydrogen peroxide goes into there. Right? Put it over there. Put it aside right now. Gonna wipe it down. Get that hydrogen peroxide off the outside. You don't want the reaction to start too early. It's taking a little longer than expected. Give me 1 second here.
After we dry the,
After you dry it off,
we pop
Put
it
it-
into the
put it in there.
phenyl oxalate,
Give it a little break.
which is the solution, the dye. And that just splattered in there.
And then the reaction's gonna start too early.
No, it's not.
That's
It's not glowing yet.
We got a little mix over here.
We have to put the top actually. Get the rest of it.
Take your hydrogen peroxide. Give it a little pour into that baby.
And now it's glowing.
Ooh, it's glowing. And now your reaction happens. Look at that. Pretty sick.
It looks better in person because it's a lot brighter.
Ooh.
Thank you for watching.
Thank you for watching. Adios.
Ben and Caleb.
Yep. Our sources: how glow sticks work, history of glow sticks, chemical and engineering news, glow stick Wikipedia, compound interest glow sticks, glow stick ingredients. Also, fun fact of the day: if you add the chemical compounds of glow sticks to Dawn dish soap, you get a much brighter reaction.
I did not know that. Wait. Oh, these, Mr. Jones, are not our actual websites. If you click on them, you'll get the actual websites. Thank you.
Thank you.
Thank you.
Adios.